Hello YouTube, I'm Olympic Fan 2 and today's video is going to be a response to an upload from a user called Shadow of Chemistry who has shown a way how to synthesize sodium nitrite from sodium nitrate and calcium sulfide. And so sodium nitrite, which is an important diacetizing and nitriting agent in organic chemistry, can indeed be pretty hard to obtain for the amateur chemist. So this synthesis not only caught my attention, but also it has raised the question of the usability and the purity of the final product. So in this first part of this video series, I am going to synthesize the sodium nitrite exactly the same way, mixing together calcium sulfide and sodium nitrate and heating the mixture for about an hour and then extracting the final product with distilled water. The second part of this video series is going to be about a quantitative analysis or redox titration using potassium permanganate to determine the final purity. Okay, so let's get started. I've already weighed out 20 grams of calcium sulfide and 8.5 grams of sodium nitrate in the right beaker. I'm using calcium sulfide dihydrate, which has a molar mass of 156.2 grams per mole. And because I'm using 0.1 grams of sodium nitrate, I only would have to use 15.6 grams of calcium sulfide, but I'm using 20 grams here to ensure that the reducing agent is in excess. The next step is to grind both materials together. And I'm using a mortar and pestle for that. So after the components have been thoroughly mixed together, I'm going to transfer them into an evaporating porcelain dish. And as you can see on the video, I'm using a fondue ethanol burner and covering the porcelain dish with some aluminum foil to ensure that no unnecessary heat is getting lost. So after lighting the ethanol fuel, the mixture is set to heat up to about 350 to 400 degrees Celsius. And if you have a thermometer, I would recommend you to measure the temperature. As you can see, I do not use a furnace for this experiment because unfortunately I do not have one available, but if you do, I would recommend to use one. But if you don't, it doesn't really matter, this works just as well. Okay, so in the meantime the mixture heats up, I've decided to perform another experiment. So as you can see, I'm transferring some sodium nitrate into a test tube. And what I'm going to do is I'm going to heat this over a blowtorch flame until it's molten. And as soon as it's molten, I will be dropping in some of the reducing agent of choice, which will be some spaghetti pieces. And interestingly, these do not even contain 0.01% of salt, so if they oxidize, they probably not going to leave any unwanted residue, which is why they are indeed pretty appropriate. For the reduction of sodium nitrate to sodium nitrite. Okay, so it's been about 1.5 hours of heating and everything has cooled down so far. So the next step will be to get everything out of the porcelain dish. And as you can see, this is probably going to be a little bit difficult with dry material. So we are adding some distilled water. And then we are rinsing everything into a beaker. Now I'm using just only about 50 milliliters of distilled water, just because sodium nitrite has a solubility of around 800 to 900 grams per liter of water. Okay, so after the mixture has been boiled for a few minutes on the hot plate. I'm going to filter it through a paper filter into an Erlenmeyer flask. And after that's been done, I will be washing the rest of the mixture with distilled water again to really rinse out any soluble material, which should hopefully only be sodium nitrite, and this is why I used the calcium sulfite in excess. Okay, so here we are. This is everything I could do. The last bit of washing was done with tap water because unfortunately I ran out of distilled water. As you can see, to avoid some splashing, I used my glass funnel to place on top of the Erlenmeyer flask. So after scratching everything from the Erlenmeyer flask, I was left with just about 1.8 grams of dried sodium nitrite. The other 0.07 grams were used for the qualitative test that you will see next. And according to the video from Shadow of Chemistry, and considering the amount of nitrate that I used in the beginning, I expected a lot more actually. So now you can see a very simple qualitative proof for nitrites. A small spatula of the product I've obtained is transferred into a test tube, followed by the addition of some concentrated or half concentrated hydrochloric acid. In theory, hydrochloric acid releases nitrous acid, which is very unstable and decomposes to form nitrous oxides and nitric acid. These nitrous oxides can easily be seen by the yellowish brown color. And as you can see, we get a positive test with our spaghetti and sodium nitrate reaction product just as well. Now, when you are performing this test, you have to make sure that you work in a very well ventilated area, because just as sodium nitrite, nitrous oxides are highly toxic. Alright, so let's summarize what we've just saw. What I started with was 8.5 grams or 0.1 mole of sodium nitrate, and the stoichiometry of this reaction, which is 1:1, means that 0.1 mole of nitrate will be converted to 0.1 mole of nitrite, or in terms of sodium nitrite, 6.9 grams. However, I only ended up with about 1.8 grams, or roughly 26% of the theoretical yield, which is probably due to some losses during the evaporation due to splashing, and mainly because I couldn't extract all of the nitrite for the soluble salts. Considering that not all of the nitrate has been converted to nitrite in this reaction, the mass that I should have weighed out could have been even higher. Now, the qualitative test has shown that we've got nitrite present in both samples. And of course, in the next video we are going to take a look at the purity. I may include also the purity of the spaghetti method, nitrate reduction. Until part 2 of this video, thanks for watching.